अस्सलाम वालेकुम एवरीवन। क्या हाल है आप लोगों के? वालेकुम अस्सलाम, वालेकुम अस्सलाम। Syllabus? That's not what I'm here for, guys. Walaikum assalam. Okay, guys, a disclaimer. So if this is the first syllabus run through that you're attending, then please note that if you're here with the intention that, if you guys are here with the intention that you can cover the entire syllabus from scratch, then obviously that's not possible. Okay? But if you just want a refresher, then that you can get through the stream. Okay? I've increased the volume, but if you just want a refresher, then that you can get through the stream. Okay? Acha, let's begin. I have increased the volume. Do you want me to increase it more? Sahi to hai? Let me see. Okay? Acha. Sahi to hai yaar. Okay, now. So I'm going to disable the chat. Sahi hai. And I will enable the chat after 1-2 topics, okay, so that if you guys have any questions, you can ask. Okay? So this stream will probably go on till, I'll end it before 9 for sure. Okay? 9 से पहले मैं इसको end कर दूंगा, don't worry. Okay? Okay, now. So first of all, please understand that in AdMaths we have AdMath topics, and there is also everything that's part of math is considered assumed knowledge in AdMaths. Okay? Everything that is part of O-level math is considered assumed knowledge, whether that is surds. Okay? Surds is considered assumed knowledge, whether that is simultaneous equations is considered assumed knowledge, whether that is sine rule, cosine rule, bearing, basic trigonometry, everything that you do in math becomes assumed knowledge in AdMaths. Okay? So I noticed that there were some questions, do we need to know bearing? Do we need to know mensuration formulas? Yes, of course. If it's part of math, you need to know it. Simple as that. Okay? See, let me give you an example. Do we do basic trigonometry in AdMaths? Do we do sine equals to opposite over hypotenuse, cos equals to adjacent over hypotenuse? Do we do any of that in AdMaths? No, we don't. Do we do sine rule in AdMaths? No, we don't. Do we do cosine rule in AdMaths? No, we don't. But do we use all these things? Of course we do. We use them in circular measure, we use them in trigonometry, we use them in vectors, we use them everywhere. Okay? So whatever that is part of math, whether that's mensuration, trigonometry, anything, is considered assumed knowledge in AdMaths. Okay, so on that note, let's begin our syllabus run through. I will start. So simultaneous, like I said, is assumed knowledge. Surds is also assumed knowledge, considering that now it's part of math. We will start from quadratic equations and expressions. So before I start, I would appreciate if you guys like the stream, if you haven't done that yet, and also subscribe to the channel if you haven't done that either. Okay, so bismillah karte hain. Let's start. And then we will take a break at Maghrib. Then we will inshallah try to wrap it up before Isha. So let's begin with quadratic. Now, what part of quadratic do we need to know? We need to know how to sketch a quadratic curve. We need to know the concept of discriminant applied to a curve and the x-axis. We need to know the concept of quadratic inequalities. We need to know discriminant applied to curve and a straight line and disguised quadratics. Okay, so these are all the concepts that we are going to cover in quadratics. Okay, first let's talk about sketching a quadratic curve. So what are all the things that you need in order to sketch a quadratic curve? You need to know its nature, whether it's minimum or maximum. You need to know its intercepts, that is x-intercepts and y-intercepts. You need to know the turning point. Okay, so how do you determine the nature? The nature is determined by looking at the coefficient of x squared. If that's positive, it's going to be greater than 0. If that's negative, it's going to be, if that's positive, it's going to be a minimum curve. If that is negative, it's going to be a maximum curve. Okay? What is A? Is the coefficient of x squared. How do you find out the turning point? You find out the turning point by bringing it from the general form to the completed square form. So how do you do that? You can do that by using the same rules that we use in math, or you can use identities also. Okay, you can use the method comparison as well. Achha. some examples. By the way, I've shared all these notes with you guys in the link in description. Let me just double check that are these notes there or not. I do see a link. I hope that's the correct one. So ये सारे notes आप लोगों के पास हैं already. You can download them, print them, whatever you want, use them as whatever. ठीक है? So I've shared these notes with you guys. ठीक है? Okay, now. Then how do you find out the intercepts? So to find out the x-intercepts, you plug in y equals to 0 and then you solve. When you plug in y equals to 0, there are three methods that you can use. You can use middle term breaking, you can use the quadratic formula, or you can use completing square. Sometimes you can't do middle term breaking, but quadratic formula and completing square, these two methods always work. Sometimes there will be no x-intercepts. That is, if you have a minimum curve which is turning above the x-axis, there will be no x-intercepts. Or if you have a maximum curve which is turning below the x-axis, there will be no x-intercepts in that case as well. How do you find out the y-intercept? Y-intercept you find by simply looking at the constant if you have a quadratic equation in its general form, or you simply plug in 0 in place of x and then you solve. Okay, and this is not just for a quadratic curve, this applies to every curve, whether it's quadratic, cubic, whether it's a straight line, it always works. ठीक हो गया? Okay, some example questions, like for example, this curve you can see has a turning point at 2, 1, so that means there is no point in finding out the x-intercepts because it's turning its minimum point. It already reaches its minimum point before it reaches the x-axis, so obviously it's not going to cut the x-axis. Okay, then there is quadratic inequality. Quadratic inequality mein what we do is we first solve it like we saw solving any other quadratic equation. We find out the critical values. Critical values are basically your x-intercepts. Once you found the critical values, so once you found the x-intercepts, what you do then is you make a curve marking the x-intercepts clearly. The x-intercepts are 2 and 6. So if the x-intercepts are 2 and 6, you look at the quadratic inequality. Greater than 0 means you want the range of x where the curve is above the x-axis. So what's the range that of x that gives you the curve that's above the x-axis? That is on the right-hand side of 6. That means greater than 6. And on the left-hand side of 2, that means less than 2. You always put a comma. You do not write and, don't write or, just put a comma and then give your answer. Okay? If, however, it's less than 0, that means you want the range of x where the curve is below the x-axis. So you highlight the part of the curve that you want. And what is the range for that part? You can see that the part of the curve where it's below the x-axis is between -4 and 5. So that means this is how you're going to write your answer. Whenever it's between two values of x, you write them in a straight line. But if it's something like this, if it's an open-ended range, isko hum bolte hain open range, then you write it separately. Okay, but if it's a closed range, if it's between two values of x, you write it like this. Some more questions. If, however, the coefficient of x squared is negative, then before you solve the quadratic inequality, make sure that you multiply both sides by minus so that the coefficient of x squared becomes positive. And when you do that, whenever both sides of the inequality are multiplied by -1, the inequality sign flips. And I've explained the logic also. If you get it, that's great. If don't, then just simply remember the rule. Okay, some example questions. Now, roots. What are roots of a quadratic curve? We determine the nature of roots with the help of the discriminant. Roots basically means the x-intercepts. Nature of roots basically means how many x-intercepts do we have. Do we have 2 x-intercepts, which means that the roots are real and distinct. They're real values. We can see them and they're different. Do we have one root, in which case we say that the nature is real and equal, or we describe and say that the curve is tangent to the x-axis, or we say no real roots / imaginary roots, which means that the curve is entirely above the x-axis, or it could also be entirely below the x-axis if it's a maximum curve. Here we say no real roots / imaginary roots. Now, how do we determine the roots? It's basically the discriminant. It's not the entire quadratic formula that we need to use. We can just use the discriminant to determine the nature of the roots. Okay? If the discriminant is greater than 0, that means this is how we can describe the nature of roots. We can say two values of x, the roots are real and distinct, and we can say that the curve cuts the x-axis at 2 points. If the discriminant is equal to 0, we say real and equal roots. We say that the curve is tangent to the x-axis, or we can also say repeating roots. They all mean the same thing. If it's less than 0, that means no real roots, imaginary roots, curve lies above / below the horizontal axis, or it's always positive or always negative. Always positive means that all y values are always positive. Always negative means that all y values are always negative. That means, so if a curve is always above the x-axis, obviously that means it's always positive. If it's always below the x-axis, if a curve is entirely below the horizontal axis, that means it's always negative. some example questions that you guys can go through. Achha, sometimes the question will not specify whether it's real and distinct or real and equal. It will only say real. So if it doesn't specify whether it's real and equal or real and distinct, you do greater than or equal to 0. ठीक हो गया? Achha, discriminant applied to a curve in a straight line. Here you can see if a line intersects the curve. So same concept. What we do is we first solve the two equations simultaneously by either plugging in the equation of the line into the curve or equating both of them and then making a quadratic equation out of it. Once we've made a quadratic equation by mixing the equation of a straight line and a curve, then once again we can apply the discriminant, but this time what is the purpose of using the discriminant? This time, if the discriminant is greater than 0, that means the line and the curve intersect at 2 points, or you have two solutions. If the discriminant is equal to 0, that means the line is tangent to the curve, or you have one solution. If the discriminant is less than 0, that means the line does not intersect the curve, or there is no solution. If the question doesn't specify whether the line is meeting the curve at 1 point or 2 points, and it only says that the line meets the curve, then notice that here also it's meeting and here also it's meeting, but here the discriminant is greater than 0, here the discriminant is equal to 0. So we combine these two and say greater than or equal to 0. Okay? All right, some example questions. Now, normally, whenever you solve a question where it's about a line and a curve and you have to use a discriminant, in the end, majority of the times, you end up with a quadratic inequality, which means you have to use middle term breaking to solve the quadratic equation, then use the concept of quadratic inequality to give your final answer. Like, for example, here it says that the line does not intersect the curve. That means once we have substituted the two equations, we've solved the two equations simultaneously, we've gotten a quadratic equation out of it. We use the concept of discriminant, we set it less than 0. What do we end up with? We end up with a quadratic inequality. We find out the critical values of x. Not x, this time it's k, but they work the same way. Now we want the range of k where the curve is below the x-axis. Why? Because the quadratic inequality that we're solving is less than 0. So that is basically for the range where k is greater than -6 and less than 2. Okay, some more example questions. Disguised quadratic. So disguised quadratic is basically when you have an equation which by the looks of it is not a quadratic equation, but the nature of terms is such that it follows the same pattern of a quadratic equation. Like for example, you have a certain power, you have three terms, the smaller power and then the larger power, and the larger power is double of the smaller power. So here you can see that the smaller power is x squared and the larger power is actually double of x squared, so it's x power 4. So you can solve it as it is by realizing it's a quadratic equation, or you can use substitution to turn it into a quadratic equation. Okay, this usually happens in trigonometry. There is sometimes a standalone question as well. Sometimes it happens in logs also. So it's up to you whether you want to do it through substitution or you want to do it directly. That's up to you. Here also you can see there are three terms, and the larger power, which is x, is actually double of the smaller power, which is half. So that means this is a disguised quadratic equation. But just keep one thing in mind, that the answer of a positive square root can never be negative. So it's not like you will square both sides and get the answer. You will be able to solve it, but it's not a valid solution. Why? Because root x cannot be negative to begin with. Okay? And that is it as far as quadratics are concerned. So now let's talk about logs. So first let's go over the rules of indices. Same bases are being multiplied, powers are added. Okay, this is a prerequisite. This is basically something that you do in math also. Same bases being divided, powers will be subtracted. Different bases, same powers being multiplied, we multiply the base, raise them to the common power. Same power, different bases being divided, we divide the bases, raise them to a common power. Anything raised to the power 0 is equals to 1. 1 raised to any power is equals to 1. If you have two powers, if you have a base raised to a certain power and the whole thing is raised to another power, the powers get multiplied. In order to make the power positive, we take the reciprocal. Then some standard rules. If you have a power m upon n, this basically means that the power on a is m and you're taking the nth root of it. Okay? Okay, now let's go over some rules of logs. So the first rule is the conversion rule. Okay, from index to log form. So if log 8 base 3 equals to log 8 base 2 equals to 3, that means we can convert them into index form. So the base is 2 here. Here also it's equal to 2. whatever value that you have after the equals to sign becomes the power on the base, and that's equal to 8. So this means 2 power 3 equals to 8. This means 3 power 4 equals to 81. You can see that. Log 25 base 5 equals to 2 means 5 power 2 equals to 25. Log 16 base 4 equals to 2 means 4 power 2 equals to 16. ठीक हो गया? So this is basically what the rule is equal to. Achha. Then you have another rule, which is log with same base and argument is equals to 1. Log with argument 1 is always equal to 0. Why? Because anything raised to the power 0 is equals to 1. So if you have a log function with 1 as the argument, doesn't matter what the base is, the answer is going to be equal to 0. Okay? Then the power rule, which we very often use to simplify logs. Normally when the question says write your answer a certain way, so if you have a log and the argument is raised to a certain power, then you can multiply the power with the argument. And remember, this rule works both ways. It works from left to right, and it also works from right to left. Okay, depending on the nature of question. All right. Then log with base 10 is called LG. So if you see LG written, that means the base is 10. So you will not see the base written with LG because LG means that the base is 10. Log with base E is called ln. If you see ln written, you will not see the base because the base is E to begin with. Okay. Achha. Then how do you solve exponential equations that cannot be solved by making bases the same on both sides? So if suppose you have 2 power x equals to 7, you can use any log function, you can use LG or you can use ln. Irrespective of what you use, you get the same answer. So you introduce ln on both sides, you get ln 2 power x equals to ln 7. X gets multiplied, so x ln 2 equals to ln 7. Make x the subject, x is equals to ln 7 upon ln 2. Now these kind of questions are usually expected in paper 2. You can't expect questions like these in paper 1, okay? But still, I may not have the time to do a syllabus run through for paper 2. In fact, I don't think I will be doing that. I'll probably be doing mocks for paper 2, which is why when you guys are done with the exam tomorrow, make sure that you give me all the fine details of tomorrow's paper, such as all the topics that were tested, including the concepts. Like for example, trigonometry here, so you need to tell me whether it was trigonometric graphs, trigonometric identities, or trigonometric equations. If it's differentiation, you need to tell me whether it's stationary value, equation of tangent or normal, rates of change, small change. Okay, so you need to tell me all that tomorrow, inshallah. Okay, some more examples. Okay, very important, because whenever you solve a logarithmic equation, not whenever, but sometimes when you solve a logarithmic equation, you may end up with more than one answer. And those two answers may not both be right. It may be that only one of them is the correct answer. So how do you make sure of that? How do you figure out which is correct, which isn't? So for a log function to be defined, its argument must be greater than 0, and its base must be greater than 0, but it should also not be equal to 1. Okay, so this is the condition for a log function to be defined. Take care. Now, I've explained the logic over here. You guys can review the notes yourself to find out how it works. Okay. So log with same bases, if they're being added, the arguments get multiplied. If log with same bases are being subtracted, the arguments get divided. Again, important whenever we have to simplify log functions. Change of base law. If let's say you have log a base b and you wish to rewrite both these values as a different base, what you can do is in the numerator, you can take the argument with a separate base, and in the denominator, you can keep the base, you can make the base the argument and have the same base as the numerator. So log a base b is equals to log a base c divided by log b base c. ठीक हो गया? When do you use this? You use this whenever you have to simplify. Then reciprocal law, if you have log a base b and if you take the reciprocal of it, it becomes 1 upon log b base a. Again, when do you need it? You need it to solve questions like these. ठीक है? Some example questions that you guys can go through. Achha. If you have an equals to sign between two log functions such that they have the same base, that means their arguments are also equal. When do we use this? We use this when solving logarithmic equations. Like for example, if you have to solve this, so we will use lots of rules of logs. So the first rule is that you have two log functions with the same base that are being added. That means we'll multiply their arguments and we'll use the power rule over here. So it becomes 3 square. Notice now you have two same log functions with the same base on both sides of the equals to sign. And if they're equal, that means their arguments must also be equal. So we equate the arguments. Notice that we get two values of y. We can only take the positive value. Why? Because we have LGY and Y cannot be negative. Since Y is the argument, Y cannot be negative, so we only take the positive value. Some more example questions, such as word problems. Not frequently tested in paper, can't be tested in paper 1, but let's go over it anyway. Acha, initial value at the start, or value at the start of the experiment basically means t equals to 0. Okay, you get questions like bacteria related. I've done this in my log stream. Bacteria ho sakta hai, population ho sakta hai, could be population of bacteria, population of a town, could be anything. Okay? Acha. So you're basically given an exponential equation and you have to work with that exponential equation. You might have to solve that exponential equation, for which you might need logs also. Okay? So some examples that you guys can go through, some past paper questions that I've solved. Okay. कितना टाइम है? 7:05. चलिए थोड़ी देर के लिए चैट खोल लेते हैं और चिट चैट कर लेते हैं, फिर हम मगरिब का ब्रेक लेंगे. Perfect speed. I know, right? Let's hope we can keep up the speed. Sir, is it necessary to mathematically find the max minimum point for drawing sine/cos graph? No. There is no need to do that. But I will not be solving any questions today. Okay, we will just be going over the notes. So whatever question related request you guys have, my suggestion is keep that to yourself. Sir, can we get bacteria questions of population density, which may have things to do with differentiation? You can, but if you get it in paper 1, that means the question is designed to be done without a calculator. Sir, is there a sequence for doing population, bacteria, etc. log questions like a general pattern? Nope, there isn't. So what do you mean by saying starting syllabus from scratch? I was saying, don't think you can watch this stream and cover everything from scratch. That's not possible. I'm expecting that you've done the syllabus and you're watching this just as a refresher. That's what I'm expecting. Okay? So should I watch the stream if I saw the full syllabus 1 from last year yesterday? I did a syllabus run through last year, then there's no need. You don't need to watch the stream if you have anything better to do. Azan यहाँ पे तो नहीं हुई. चलें जब होगी तो we'll take a break. So in paper 1, do we have to keep answer in decimal or normal fraction? Up to you. But my suggestion is keep it in fraction unless the question says otherwise. So will marks be awarded if I solve questions with accurate drawing? Of course not. Of course not. So circles and velocity vectors review, please. But I can't just drop everything and review what you want me to review. I will do a syllabus run through of all the topics. So just hold it. Okay, hold it. Be patient. What do we do after the stream? You go sleep. In fact, if you want to do that right now, go sleep right now. No need to watch the stream. Can linear law be tested in paper 1? Yes, it can be. In fact, in the second mock that we did, was it the second or the third? I don't know. But in that mock, I gave you guys a linear law question in paper 1. Will this run through be enough for revision? I don't know, Minahil, what is the state of your preparation, but if you've done all the topics and you're looking for a refresher, then yes, that's the maximum purpose this stream can serve. Will we get kinematics? Peter, what do you think? You think I made the paper? You think I made the paper? Yeah, you think they ran every question through me, or they asked me, okay, what questions do we give? Sir, bata दें. अपने बच्चों से पूछ के कि हम ये सवाल दे दें या ये ना दें. I don't know. ठीक है? I don't know. You guys find out and tell me tomorrow. ठीक है? चलें, let's take a break. Let's take a namaz break. We will resume inshallah after namaz. So see you guys in like 15 minutes tops. Okay, guys. So, let's resume. We are now on our third chapter, which is polynomials. Now, polynomials includes remainder and factor theorem. Polynomials includes solving a cubic equation. It includes sketching, and it includes cubic inequalities. Okay? Achha, let's begin with remainder and factor theorem. So, remainder and factor theorem basically is used to solve a cubic equation. Okay, it's the first step towards solving a cubic equation. If a polynomial p of x is divided by x minus a, the remainder is p of a. That means if you have a polynomial which is divided by a linear expression, all you have to do is equate that expression to 0, find out the value of x, plug in that value of x in the polynomial, and whatever you get as the answer is the remainder. Okay? Now, remainder theorem is used only when the remainder is needed. Another example, if it's divided by x plus 1, this polynomial, you plug in x equals to minus 1, whatever you get, the answer is 0. The answer is the remainder. Achha. There is another way to actually do that, and that is through long division. But the thing is, long division is only used when we have to solve a cubic equation. Okay, so long division we use when we're asked to solve, factorize the equation / expression. Okay? Achha. If the remainder is equals to 0, how will I know that so-and-so expression is a factor of the polynomial? The remainder is equals to 0. If the remainder is equals to 0, that means that expression is basically a factor of the polynomial. Okay? Achha, how do you solve a cubic equation? The way that you solve a cubic equation is that you find out the first factor through trial and error. That means you look at the constant and you multiply the constant with the coefficient of x cubed. What is that equal to? That's equal to 10. What are the factors of 10? It's 1, 2, 5, and 10 with plus minus. Now you randomly start plugging in values. Okay, you first plug in positive 1, then minus 1, then positive 2, then minus 2. And this you plug in values in the same order. Okay? Now you keep doing that till you find one value which gives the remainder 0. So x plus 1 gives you the remainder equals to 0. That means now to find out the remaining two factors, the most preferred method is through long division. Okay, I'm not saying long division is the only method, but the most preferred method is long division. So you take the polynomial divided by the factor that you've just found. The quotient is going to be a quadratic expression, and now in order to find out the remaining two factors, you further factorize the quadratic expression, and now you have two more factors and one factor that you found through trial and error, and now you can write it in factorized form. Okay? There's synthetic division also. If you're aware of synthetic division, there's identities also. If you're aware of that, use that, but now is not the time to experiment. Stick to the method that you're the most comfortable with. Okay, here's synthetic division, but remember, synthetic division we only use if we're asked to solve, not if you're asked to factorize. Okay? Okay, some more example questions. All right, now, sketching a cubic curve. Now, a cubic curve can have maximum 3 x-intercepts, okay, minimum 1 x-intercept. And if it has 2 x-intercepts, so the point where the curve is tangent, you will find a square over there. Now, what do you need to sketch a cubic curve? You need the x-intercepts that you find by equating y to 0 and solving for x. You need the y-intercept that you find by plugging in 0 in place of x and solving for y. And then the nature, the most important part. So if the coefficient of x cubed, k is the coefficient of x cubed, all right? If it's positive, then that means you have a maximum to minimum curve. If the coefficient of x cubed is negative, that means you have a minimum maximum curve. Achha. Now, if you're asked to sketch, for example, this cubic curve, first you will find out the x-intercepts. So the x-intercepts are 1, 3, and 2. You mark the x-intercepts. You find out the y-intercept, which is minus 6. Now, what is the coefficient of x cubed? You don't have to expand this entirely. Just multiply all the x's from the bracket and see what you end up with. You end up with a positive x cubed, which means that this is going to be a maximum minimum curve. Okay? Just make sure that the turning point is somewhere in between the two x-intercepts. Always somewhere in between the two x-intercepts. Like for example, over here, the two x-intercepts are minus 1 and 2. So just make sure that the curve turns somewhere in between. Okay? Meaning if you draw it like this, then this is obviously not right. Make sure that it's turning somewhere in between the two x-intercepts. Not exactly in between. You need that you take a scale and you measure it correct to the nearest millimeter. That's just a total waste of time. They're not perfectly symmetrical anyway, but they are somewhat symmetrical. Okay? If you find a square on a certain bracket, that is the point where the curve is going to be tangent to the x-axis. ठीक हो गया. अच्छा, अब quadratic inequalities. Now quadratic inequality once again is solved like a cubic inequality. You can only do it after you've made a rough sketch. Without it, it's very difficult. So just make sure that you first make a rough sketch before you start. वैसे तो normally a cubic inequality question is designed in a way that you are first asked to sketch, then there is a follow-up question, or maybe you're given the sketch and then there's a follow-up question on cubic inequality. Now if let's suppose the question says greater than 0 means you want the range of x for which the curve is above the x-axis. So what's the range of x for that? It's on the left hand side of p, that means it's less than p. Here's that, and between these two values q and r, so that means x is greater than q and less than r. If it's below, so highlight the region that's below the x-axis, so you can see that these two parts of the curve are below the x-axis. So the first part is where x is greater than p less than q, the second part is where x is greater than r. ठीक हो गया? Okay, some example questions, some more example questions. Also, how do you find out an expression? So we did this recently only. First, you look at the x-intercepts and you work your way back. If x-intercepts are -3, 1, and 5, that means before we found the x-intercept, this must be x plus 3, this must be x minus 1, and this must be x minus 5. Now you leave a constant for the coefficient of x cube. Now how will you find out the coefficient of x cube? You need other than these 3 points, you need one more point through which the curve is passing, that is the y-intercept. So you plug in -5 in place of y, you plug in 0 in place of x, and you find out the coefficient of x cube, and you can see I've done that over here, and this is the complete equation now. Okay? Okay, now let's have a look at coordinate geometry of a straight line. So coordinate geometry of a straight line is mostly formulas, nothing more than that. So you have the distance formula, distance between 2 points, x2 minus x1 the whole thing square plus y2 minus y1 the whole thing square. I've done a little derivation of it in case you're interested. Then you have the gradient formula. What's the gradient formula? It's y2 minus y1 over x2 minus x1, which is basically rise over run. Okay. Then collinear points, remember collinear points are points lying on the same straight line and they have the same gradient. Then parallel lines also have the same gradient. Achha, then I've made a little table here where I've talked about what will be the gradient of a parallel line be equal to and a perpendicular line be equal to equation of a straight line that's equal to y equals to mx plus c. But in ADMATS we have a different form, that is y minus y1 equals to mx minus x1. Now looking at the line, you should be able to identify what its equation is going to be like. If it's an upward sloping line, it's going to have a positive gradient. If it's downward sloping line, it's going to have a negative gradient. If it's a horizontal line, that means its equation will be y equals to c. If it's a vertical line, its equation will be x equals to b, where b is the point at which the line cuts the x-axis and c is the point at which the line cuts the y-axis. Okay. Some more example questions. Equation of perpendicular bisector. How do you find out the equation of a perpendicular bisector? You first find out the midpoint, then you find out the gradient of line AB, then you take the negative reciprocal of the gradient, then the midpoint is the point from where the perpendicular bisector will pass. We've already worked out the gradient, so you use the gradient and the midpoint to find out the equation of the perpendicular bisector. Then there is this formula which is known as the shoelace method. Okay. But I haven't really come across a question where you only have to use this formula and it can't be done the other way. So if this is something that you're familiar with, good. If it's not, then not something that you have to learn from scratch. Okay, but it's one of those good to know things. So you can use this formula to find out the area of any polygon there is. I repeat, any polygon, as long as you know all the coordinates of its vertices. So you write down the coordinates of the first point, the second point, the third point, and all the points, except that in the end you rewrite the first one again. Okay, you can see that in the end I've rewritten the first one again. Then you first multiply from left to right. You can see that we first multiplied left to right. Here you can see left to right multiply kiya. We've added all these values. Then you multiply from right to left. You add all these values. Then you subtract the two sums. And then you multiply it by half. Notice that there's a modulus sign over here. Modulus sign basically means that whatever value that you get in the end, you're supposed to take the positive value. Why? Because we're finding out area, and we know area is something that can only be positive, not negative. Okay? Okay, now. Okay. So these are some important properties that you must remember. Square, for example, has equal diagonals. The diagonals intersect at midpoint and the diagonals are perpendicular. Rhombus does not have equal diagonals, but the diagonals are intersect at midpoint and they're also perpendicular. Rectangle, equal diagonals, intersect at midpoint, but they're not perpendicular. Parallelogram, only that the diagonals intersect at midpoint. Okay, then there's kite also, which has perpendicular diagonals. Okay, some more example questions. And in the end, there is linear law. Now, linear law is also something that can come in paper 1 or paper 2. Okay. In the second mock, there was a question of linear law in paper 1. If it comes in paper 1, whatever question comes in paper 1 from whatever topic, if it comes in paper 1, that means it's designed to be done without a calculator. Okay. So in linear law, what we do is whatever is taken on the y-axis, we replace y with that in the straight line equation, and whatever is drawn on whatever we take on the x-axis, we replace x with that in the equation of a straight line. So for example, if it's 1 upon y against x squared, when we write down the equation of a straight line, it's 1 upon y equals to mx squared plus c. Okay. Then there are some example questions that I've solved. And yeah. Okay, then let's look at coordinate geometry of a circle. So the first and the most important thing of a circle is its equation. What do you need to write down the equation of a circle? You need its radius and the center. If you have these two pieces of information, you can form the equation of a circle. Or you need 3 points on the circumference. Why? Because if you have 3 points on the circumference, then what you can do is you can find out the radius and you can find out the coordinates of the center also. So x minus a the whole thing square plus y minus b the whole thing square equals to r square, where a comma b is the center and r is the radius of the circle. I've done a little derivation here in case you care. Some simple example questions, some more example questions. Yeah. Then there are some circle properties that you must know. One is angle opposite the diameter is equals to 90 degrees, very important. Okay? And the condition is that the angle is drawn on the circumference. If it's not on the circumference, this property will not hold. And here is an example question where we have used this property. Then there is this property, not something that I've seen used very often, but remember, everything that's part of math becomes assumed knowledge in math. Simple as that. That is, if you have two chords that are equal in length, its distance from the center will be equal. Or if you have two chords that are equidistant from the center, that means their length must also be equal. Then if you have two tangents intersecting at an external point, what does that mean? That means the two tangents are equal in length. Now, I haven't even seen this property used anywhere, but it's still an important property nonetheless. Okay? How do you find out the equation of a circle? If you're given 3 points on the circumference and there is no 2 points or endpoints of the diameter, then what you do is you first find out the perpendicular bisector of two sets of points, then you find out the perpendicular bisector of the other set of points. Okay? Now, both these perpendicular bisectors will pass through the center. Then you solve the two equations simultaneously to find out the coordinates of the center. Once you have the center, you use the center along with any other point to find out the radius of the circle. Okay? That's the standard rule. Intersecting circles, ये आपको याद करना पड़ेगा. ठीक है? If the distance between the two centers is greater than the sum of the radii, that means the circles do not meet. Okay? That is one way that the two circles cannot intersect. If the distance between the two centers is less than the difference of the radii, again, you'll have to memorize this. Okay, you'll have to memorize this. Then also, this is a condition where the circles do not meet. If the distance between the two centers is exactly equal to the sum of the radii, the circles touch. If the distance between the two centers of the circle is exactly equal to the difference of the two radii, then also the circles touch, but the condition is that one circle is inside the other. Okay? Then there is intersecting circle, that is if the distance between the two centers is less than the sum of the radii. You'll have to memorize this. I'm afraid there is no other way to it. Okay? Whenever two circles intersect, they will have a common chord. And what is that common chord? That's this right here. That common chord will be the one that is basically you will get a kite. What you will get as a result is a kite. Okay? And one of the diagonals of the kite will basically be a common chord, and the other diagonal will basically be connecting the two centers of the circle. So you'll have to memorize this. There is no other way to it. You'll have to memorize it. Okay? Some example questions related to the concept that we have just learned. Some more example questions. So this concept has only been tested once, that the circles do not intersect. Like for example, the question says, show that C and the circle with the equation x squared plus y squared do not intersect. So this is the equation of circle C. The distance, the center of the circle is 5, 12. The center of the other circle is 0, 0. The radius of this circle is 10. Radius of the other circle is 2. So distance between the centers is 13. And the sum of the radii is equals to 12. So notice that the distance between the two centers is greater than the sum of the radii. That means the circles do not intersect. Okay? Okay, now let's move on to chapter number 8. फिर उसके बाद मैं थोड़ी देर चैट खोल दूंगा. फिर you guys can say what you want, and then we will continue. Now, binomial theorem, something that I did a stream on recently. It's very easy. Couple of things that you must know is that if binomial, basically bi means 2, nomial basically mean terms. So if you expand a binomial, then whatever the power is, the total number of terms will always be 1 more than the power. Okay, that is if you expand it all the way through. Sometimes the question will not ask you to expand it all the way through. In fact, majority of the times it doesn't. It only asks you to find out up to a certain power in x. Like for example, up to x cube, up to x square. Okay, that is what it does. Okay, here's an example. So how do you start expanding? You start by taking r. R is something that can only take integer values. You start from 0 and it goes all the way to n, where n is the power. Okay, so here you can see I've done an expansion of 1 plus x, the whole thing power 5. If the first term is 1, then in the expansion also the first term will be equal to 1. So you can see I've expanded the whole thing. We've ended up with a total of 6 terms. Because the power was 5, the total number of terms are 6. Okay? Okay. Now, some rules. If let's say x is in the second term, like for example over here, then whatever is the value of r, that will be the power on x. Like for example, if you expand using r equals to 4, you'll get x power 4. If you expand using r equals to 2, you'll get x power 2. Okay? So this is how we, for example, if this is the binomial, if this is the binomial expression and you're asked to find out x power 10. So obviously you're not going to expand it all the way through. So since x is in the second term, we know that if we take r as 10, we will get the value, we will basically get the coefficient of x power 10. Similarly, if we take r as 2, we will get the coefficient of x squared. If the question is categorically asking for the coefficient, make sure that you only give the coefficient, not x with it. Okay? Some more example questions. Achha. If x is in the first term, then the value of r is n minus the power on x. Meaning, for example, if let's say you want x power 3, then Achha, ab ye, it's not that you have to sit down and memorize these rules. You can just figure it out there and then. If let's suppose you want 3 to be the power on x, that means you will make sure that the power on 4x is equal to 3. Now, what is the power on 4x equal to? It's 7 minus 3. So that means you will make sure that 7 minus r, you'll make sure that 7 minus r equals to 3, which means that r is equals to 4, which means that if you expand with r equals to 4, you will get the coefficient of x cubed. Okay? Rule is that it must be equal to n minus the power on x. Okay, if x is in both terms, also something that is frequently tested, then you expand using the formula NCR, a raised to the power n minus r, b to the power r. And what you do is you ignore every constant. You ignore every constant and you focus on x only. So x power 5 minus r, 1 upon x power r, which we shift x in the numerator, so it becomes x power minus 1 to the power r. So the powers get multiplied, same bases are being multiplied, so the powers will be added, and we equate it to x power 1, and this is the value of r that we end up with. Independent of x, remember, means that x power 0. So an exceptional case where all you need to use is your common sense. This is very important. This is the part of binomial. This is the part of permutations and combinations that I expect can be tested in the non-calculator paper. That is the expansion of NCR without a calculator. So these are some rules that you must know. ठीक है, वैसे तो इसका पूरा formula है. That's given in the formula sheet also, but you must know how to expand it as well. Meaning NC0 is equals to 1, NC1 is equals to n, NC2 is equals to n into n minus 1 upon 2 factorial. NC3, you can see the pattern that the numerator has exactly the number of terms as r starting with n, and every following term is 1 less, and the denominator is basically r factorial. ठीक है, ये इसका official formula है. ठीक है. Achha, some example questions that I've done. I did a question similar to this in the binomial stream also that I did very recently. Okay, so you guys can watch that. I've lately noticed that there are some very difficult questions of binomial that are being tested. So, not something that you guys should take lightly. Acha, so let me open the chat for a while, see what you guys are up to, see if you guys are awake or whether you've fallen asleep. सो गए आप लोग? चलें, सो गए तो मैं बंद कर देता हूँ स्ट्रीम. Sir, can we use Pascal triangle in binomial expansion? Yes. If you're aware of it, then yes, you can. How much time should we save for rechecking? You should check as you go along. Check as you go along. Remember the 3-2-1 rule. 3 lines of working, pause for 2 seconds, review it once. Okay. Linear law क्या था? Linear law is linear transformation of data. Do we have to learn formulas for mensuration? Yes, you do. You do. Can we use pencil for big questions? No. No, don't use pencil. Beta, I did a stream recently on binomial where I solved some really difficult questions as well. Okay? Make sure to check it out. What to eat before exam? Just don't experiment with yourself. Don't experiment with yourself. Don't do anything that's out of routine. Okay? Don't experiment with yourself. Don't do anything out of routine. It's not recommended. Okay? Yes, in linear law, we find the gradient using the given values. That's correct. So we need to memorize the formula of cylinder cone. Everything that you do for O-level math, you do for AT maths as well. Everything that's part of Dekho, I can't make it more clearer than this. Everything that you do in maths becomes assumed knowledge in AT maths. Simple as that. Okay, now if you've done enough past paper questions, I'm sure tomorrow will not be the first full-length paper that you will solve. Okay, if you've done enough past paper questions, you would know whether you need to know the formula of a circle, of a sphere, of a cylinder, of a cone, of a pyramid, of a prism. ये सब आपको पता होगा अगर आपने enough past papers किए हैं. अगर आपने नहीं किए हैं तो बेटा चिल करें आप. ठीक है, आपको ज़्यादा टेंशन लेने की ज़रूरत नहीं है. कल ही देखेंगे क्या होता है. ठीक है? Okay, now let's resume. Okay, so APGP. APGP, also another easy topic, can be tested in paper 1, can be tested in paper 2. Okay, so arithmetic progression, exactly the same as that you do in math. How do you identify it's an arithmetic progression? If every following term is, if 2 consecutive terms have a common difference throughout, or if you're constantly adding something, or if you're constantly subtracting something to get to the next term, then it's an arithmetic progression. A geometric progression is where you're constantly multiplying it by a certain term to get to the following term, to get to the preceding term. Preceding is what comes after, preceding is what comes before. Then it's a geometric progression. Okay, now, in an arithmetic progression, there is a common difference, which basically is the difference between any 2 consecutive terms. In a geometric progression, there is a common ratio, which is basically the difference, the ratio of any 2 consecutive terms, such that we put the preceding term first and then under it the preceding term upon the preceding term. So how do you find out the nth term of an arithmetic progression? It's a plus n minus 1 into d. Okay? How do you find out the sum? For sum, there are 2 formulas. The 2 formulas that we have are 2a plus n minus 1 into d. So you use this formula when you don't know the last term, but you know the number of terms, you know the first term, you know the common difference. And you use this formula if you don't know the difference, but you know the number of terms, the first term and the last term. Okay, so it depends on the situation, what situation you're in, and depending on that, you decide to use the formula. Some example questions. Now let's talk about geometric progression. This is the formula for finding out nth term, which is a r raised to the power n minus 1. A is the first term, r is the common ratio, n is the term that you need. Now sum has two formulas. Now you can use either one of the two irrespective of the value of r. ठीक है, a lot of people say कि नहीं ये वाला formula तब use करेंगे, ये वाला जब use करेंगे, ऐसा नहीं है. You can use any formula irrespective of the value of r, because even if let's say r is greater than 1 and you end up using the formula where r is supposed to be less than 1, this will be negative and this will be negative and they will cancel out, and in the end you will end up with the exact same answer irrespective of the formula that you use. Then there is sum to infinity. Sum to infinity only exists if the common ratio is between -1 and 1. You will often come across question where it says, okay, find out whether sum to infinity exists or not. So remember, the rule is that if the common ratio is between -1 and 1, the sum to infinity will exist. ठीक है? Okay, now some example questions that I've solved which you guys can review. APGP is nothing except for formulas. Achha, I've done a formula derivation which is not exactly relevant. Achha, make sure you're reading the question carefully. Like for example, there was this question where a student struggled a lot. It gave us the sum of the first 30 terms, then it gave us the sum of the next 20 terms. So there is no independent formula for the sum of the next 20 terms. What we had to do was, we had to combine these two sums to find out what? To find out the sum of the first 50 terms. Okay, so we can make one equation with the help of this, but we can't make any equation just with the help of this. That is why we combine these two pieces of information. We find out the sum of the first 50 terms, then we use these two pieces of information to find out the first term and the common difference. ठीक हो गया? अच्छा, then comes circular measure, also something that can be tested in paper 1. In fact, lately I have noticed some questions that of circular measure in paper 1, but if it comes in paper 1, remember, you will either keep it in terms of r and theta, or you will find out the exact values. Achha, circular measure is also all about formulas. So first of all, remember how to convert degree to radian. Okay, if you have an angle in degrees and you wish to convert it into radian, simply multiply it by pi upon 180. And if you have an angle in radian and you want to convert it into degrees, simply divide it by pi upon 80 or multiply it by 180 upon pi. Okay, now for some angles, if you remember the values, it will save you some time. Like for example, 60, 45, 30, 90, 180, 270, 360. Okay? Achha. Area of circle, irrespective of whether it's degree or radian, the formula is pi r square. Same goes for circumference, it's 2 pi r. Area of sector, the formula that we will use now is 1 upon 2 r square theta, or half rs. Okay, rs, where s is basically the arc length. Okay? Arc length is s is equals to r theta. This is the formula that we will use. Perimeter is equals to r plus r theta. Area of triangle, exactly the same formula. Sine rule, exactly the same. Cosine rule, exactly the same, except that it will all be done in radian mode if you're solving a question where you can use a calculator. Okay, if this comes in paper 2, so you will obviously use a calculator, but you'll make sure that your calculator is in radian mode. Okay? In circular measure, doesn't matter whether it's paper 1 or paper 2, make sure that you plan your answer. Okay, especially if you have those areas or perimeters of complicated shaded shapes, then it's very important that you plan your answer. ठीक है, प्लानिंग में आपने ज़रा थोड़ा टाइम लगाना होगा. जब प्लानिंग क्या हो सकती है? प्लानिंग ये सिंपल सी एक स्टेटमेंट भी हो सकती है. Okay, macro planning, not to the fine details, but simple basic planning. Like for example, if you want to find out the area of shaded region, it's important that you plan your answer. Here, this is the planning that I've done. ठीक है? Okay. I gave a question. Yes, so for example, these are the kind of questions that you can expect in a non-calculator paper. Okay, where everything, notice the question says find in terms of r and theta. So it will be a question where everything is in terms of r and theta. These are the kind of questions that you can expect in paper 1. Okay. Okay. So permutation and combination. Now, a lot of you have been asking me about permutation, combination. Paper 1 में आ सकता है, नहीं आ सकता, आ सकता है, नहीं आ सकता. So देखो, the only part of permutation and combination that I have seen tested in paper 1 are questions like these. ठीक है? These are the kind of questions that I have seen tested in paper 1. That is NPR without a calculator. So what's the general formula? The general formula is n factorial over n minus r factorial. These kind of questions, the regular questions, I haven't seen questions like these being tested in paper 1. I'm not saying they aa nahi sakte, but I haven't seen them. So we'll take a small risk and we will leave these for paper 2. ठीक है? अभी जो है, the kind that is usually tested in paper 1, let's focus on that only. Okay, which is why you guys need to come back to me tomorrow and tell me exactly the topics that were tested, topics with concepts, so that we can prepare better for paper 2. Okay? Now, how do you expand NP1? NP1 is equals to n. How do you expand NP2? NP2 basically means n into n minus 2. How do you expand NP3? NP3 basically means n into n minus 1 into n minus 3. Achha, if you use the formula is n factorial over n minus r factorial. So NP3 basically means n factorial over n minus 3 factorial. Now n factorial, if I start expanding this, it will be n into n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5. We'll keep on going. But how about we stop at n minus 3 factorial? Why did I deliberately stop at n minus 3 factorial? Because that's what the denominator is as well. So when we cross it out, you notice that you get the exact same thing. Now you can do it with the formula, you can do it without the formula. Doesn't matter. Irrespective, you get the same answer. ठीक है? अच्छा, so अभी तक मैंने P के भी questions वैसे paper 1 में नहीं देखे. मैंने जो questions देखे हैं वो basically इस तरह के questions देखे हैं. NCR without a calculator. Yeah, these are the kind of questions that I've seen. The number of combinations of n objects taken 4 at a time is equals to 6 times the number of combinations, and the number of combinations of n objects taken 2 at a time. So n objects taken 4 at a time, that means NC4 is equal to 6 times the number of combinations of n objects taken 2 at a time. That means 6 into NC2. Now how will you expand NC4? N into n minus 1 into n minus 2 into n minus 3, 4 terms in the numerator. In the denominator, we'll have 4 factorial, which is equal to 24. This is equal to 6 times NC2. NC2 means n into n minus 1 divided by 2 factorial, or simply 2. Notice we get a quadratic equation out of it. We solve. N obviously can only be positive, so the answer is n equals to 11. Another example question. अच्छा ये भी देख लो. ये भी एक बड़ा अच्छा सवाल आया था. n plus 9 into n p10 plus n square plus 243 into n minus 1 p9. Find the value of n. Okay, so np10 basically means n factorial over n minus 10 factorial. We're using the formula over here. Why? Because if I write np10, if I expand and write np10, that's not feasible. And then n squared plus 243 as it is, then n minus 1 p9. N minus 1 p9 basically means in the numerator we'll have n minus 1 factorial, in the denominator we'll have n minus r factorial, which means n minus 1 minus 9 factorial. Now n minus 1 minus 9 is n minus 10, so this becomes n minus 10 factorial, this becomes n minus 10 factorial. N factorial can be written as n into n minus 1 factorial. Why am I doing that? It's not that I'm just doing stuff randomly. Notice that we have eliminated n minus 10 factorial from both sides of the equals to sign. Here we have n minus 1 factorial, here we have n factorial. So can I rewrite n factorial as n into n minus 1 factorial? Of course I can. Purpose is so that I can eliminate n minus 1 factorial from both sides. And when I do that, this is what we end up with. N plus 9 into n, so that's n squared plus 9n, equals to n squared plus 243 equals to n squared plus 243. We actually end up eliminating n squared as well, and we end up with a linear equation, which is why we only get one value of n. So we don't have to worry about which one's legit and which one's not legit. Okay, so these are the kind of questions that you can expect in paper 2. In paper 1, sorry. ठीक हो गया? Okay. Vectors. Vectors, vectors, vectors. Why do we have so many blank pages? Okay. Now, for the most part, AddMath vectors is very similar to math vectors. So remember that you can write a vector in column vector form, you can write the vector in IJ form, okay? Or you can write it by using any letter to express it, okay? Now, what is the magnitude of a vector equal to? The magnitude of a vector is equal to square root of x square plus y square. Okay? That is basically the length of a vector, and that only applies when you have found, when you have basically written it as a column vector. Okay? Now what are equal vectors? Equal vectors are vectors with the same magnitude and direction. Okay? So two vectors, only if they have the same magnitude and the same direction, will be considered equal. What are negative vectors? Same magnitude but opposite direction. Like for example, 4 and minus 3, change the direction, opposite kar do direction, minus 4, 3, therefore they become negative vectors. Parallel vectors, they are same / opposite direction but different magnitude, but they are in the same ratio. Meaning, if you take the x component of this vector, divide by the x component of the other, take the y component of this, divide by the y component of this, you get the same ratio. That means they're parallel. Okay? If the constant is positive, that means they're in the same direction. If the constant is negative, that means they're in the opposite direction. Basically, two vectors are parallel when one vector is a scalar multiple of the other. ठीक हो गया? Okay, some example questions that I've done. अच्छा, अब mostly the questions आते हैं आपके पास. अच्छा, ये भी देख लो. Addition of vectors में we use the head to tail rule. If the head of the first vector is equals to tail of the other, that means they can be added. In subtraction, it's that the starting point must be the same and the letter that's near the equals to sign comes near the equals to sign on the other side. The letter that is far remains far away from the equals to sign on the other side. What's position vector? Position vector is a vector relative to origin. So any point, if you want to write it in vector form, you need to add an O before it, and then it becomes a vector, and then you can write it in either column vector form or you can write it in IJ form. Okay, I is basically nothing fancy. It's representing horizontal movement. If it's positive, it's towards the right. If it's negative, it's towards the left. And J also is nothing fancy. It's only representing vertical movement. If it's positive, it's up. If it's negative, it is downwards. Okay? Some example questions that I've solved. Okay, what's the unit vector? Unit vector is vector divided by its magnitude. Okay? Remember, magnitude of any unit vector is always equal to 1. Okay? Okay, some example questions that I've done, some more example questions. Achha, these are the kind of questions that you will expect very often. Okay, and I've done a stream on this recently. You guys can check it out. You will always get questions like these. Not always, but you will very often get questions like these where you will find two vectors using two different constants, like for example, OX in terms of MP and Q, OX in terms of NP and Q. Then you will have one vector expressed using two different equations, and since it's the same vector, that means the equations are equal, which we then compare to find out the value of M and N. Very, very common. Achha, then comes velocity vectors. Velocity vectors is something that is not tested too often in paper 1, but it can be tested, so हम इसको briefly ज़रा go through कर लेते हैं. Now, what is velocity equal to? Velocity is basically something that has magnitude and direction. Okay, now how do you use velocity vector to find out speed? The magnitude of the velocity vector is equals to speed. Okay, so if you're given the velocity will be given in IJ form and you're asked to find out the speed, simply take its magnitude. How do you find out the velocity vector? Using the speed and its velocity. So what you do is you combine the two. If let's say you're given that it's traveling northeast at a speed of 3 under root 2. So you make a triangle. Northeast means that it's going to make a 45-degree angle with the horizontal, okay, because this is what northeast means. So the horizontal, the adjacent side will basically represent the x component, the opposite side will basically represent the y component. Okay? So we find out the horizontal component. Technically, ये paper 1 में आ सकता है because they can give you values of which you're supposed to remember what sine, cos, and tan is equal to. Okay, so for example, 0, 30, 45, 60, 90. So cos 45 equals to adjacent over hypotenuse. That gives you the horizontal component of velocity. Then sine 45 equals to opposite over hypotenuse. That gives you the vertical component. Okay, if you're given bearing, then if the bearing is, let's say, 120 degrees, that means you need to first make a 90-degree triangle out of it. 120 means 120 starting from the north. That means the angle from the horizontal is 30 degrees, and then you will decide which one's going to be positive, which one's going to be negative. So if the object is going in this direction, that means the horizontal component will be positive, the vertical component will be negative since it's going down. Acha. another important formula, velocity vector is equals to speed multiplied by unit vector of direction vector. So if you're given the speed and you're given the direction in which it's going, so calculate the unit vector of the direction vector multiplied by its speed. That's how you get the velocity vector. Okay, how do you calculate the distance using the displacement? You simply find out the magnitude. Displacement will be in ij form, distance will be a value. If you calculate its magnitude, you get the distance. ठीक है? अच्छा. Some questions. अच्छा, if an object is, ये important equation है, s equals to a plus vt. The displacement of an object moving at a constant velocity is a plus vt, where s is what? S is the displacement after t hours, a is the position vector of the starting point, v is the velocity vector, and t is time in hours. Okay, I've explained this concept in a stream that I did this year only for this session, so you can check it out. ठीक है. अच्छा, इसमें a lot of students ask this question कि how do we know whether two objects are colliding or not? Very simple. To find out whether two objects are colliding or not, you simply equate their position vectors at t hours. If they are colliding, you will get the same value of t by solving both the equations. If the values of t are different, that means they are not colliding. ठीक है. अच्छा जी, ये हमारा vectors भी हो गया. Next is trigonometry, functions, differentiation, integration, kinematics. ठीक है. Trigonometry. अच्छा, मैं थोड़ी देर के लिए chat खोल देता हूँ. See what you guys are up to. अच्छा, how do we, okay, now last year's stream was better, तो बेटा last year वाली देख लो, इसमें तो टेंशन की क्या बात है. A sketching of exponential graph, I did some questions yesterday also, and I will do it in functions also. ठीक है. Last year I don't think I did 3 streams in one day. Today I had to do 3 streams in one day. That is why. How many yearlies are enough? There is no magic number. So how to find time t when they collide? If they collide, equate their position vectors. If the value of t that you get by solving both the equations is the same, that means they're colliding. Simple as that. ठीक है. देखो, you should know all the identities. You should know, by identities I mean complementary, supplementary. You should remember the shape of sine, cos and tan. And you should know the sine, cos, tan values of 0, 30, 45, 60, 90. So when do we use the greater than or equal to sign in discriminant? If it says real roots. If it does not specify whether it's real and equal or real and distinct, if it only says real roots, then you do greater than or equal to 0. So have you already done permutations and combinations? Yes, I only did the NCR and NPR part of permutations and combinations, which is what I expect to be tested in paper 1. ठीक है. देखो, मैं आप लोगों को एक सवाल ही दिखा देता हूँ यार. देखो, here are two particles A and B. Okay, here are two particles A and B, and the question says Okay, find the time when the particles collide and the position vector of the point of collision. So here the question has told us that they are colliding. So notice that we've taken the position vector of one object, we've taken the position vector of the other object. We equate them, okay, and when we equate them, we solve for the value of t, we get the value of t equals to 6. But let's say that we have to find whether the two objects are colliding or not. Okay, let's say we have to find whether the two objects are colliding or not. What will we do? We will solve this equation, find out the value of t, and we'll solve this equation, find out the value of t. If we get the same answer for both, that means they are colliding. If we don't get the same answer, that means they're not colliding. ठीक है? जैसे मैं एक और सवाल देख लेता हूँ. I hope I can find it. Show that the two boards will collide. Okay, so we found the equation of both the boards. This is the equation of one board. This is the equation of another board. Okay. Now we equate their position vectors at time t. Okay, so I equate these two. You can see I've color coded it. Green se underline kya hua hai? That means that's this equation. What do we get? We get t is equals to 200. Okay. And then 1.15t upon 2, I've equated it with this. Notice that here also we get the same value of t. So when we get the same value of t, that shows that the boards will collide. ठीक है? इससे ज़्यादा मैं अच्छा देखो अब जैसे यहाँ पे सवाल कह रहा है कि determine whether p and q collide. So this is the position vector of board p. This is the position vector of board q. So we equate their position vector. When we solve these two, when we solve this equation, we get one value of t. When we solve this equation, we get another value of t. They're not equal, therefore they do not collide. Simple as that. ठीक है? Okay, now trigonometry. Achha, what are the concepts to cover in trigonometry? The introduction to three quadrants. We will not go over trigonometric equations because I don't expect that to be tested in paper 1. Use of calculators, so obviously we're not going to go through that. So remember the quadrants. The first quadrant, all trigonometric ratios are positive. The second, sine is positive. The third, tan is positive. The fourth, cos is positive. Okay? You can remember this by ASTC. It's complementary angle identities that you must be familiar with. Sine 90 minus theta equals to cos theta. Cos 90 minus theta is equals to sine theta. Tan 90 minus theta is equals to 1 upon tan theta or cot theta. Okay? Achha. Here you have supplementary angle identities. What are supplementary angles? Supplementary angles are angles that add up to 180 degrees, similar to the ones that we had in math, except that we did not have tan in math. Here we have tan as well. Okay? The negative angle identities, again, something that you must remember. Achha. Then we did a whole trigonometry related stream today. This is the table that you must remember. Okay? I've made a video as to how you can memorize this table easily. Watch that video to understand how it works. Okay? It's really not that complicated. Ye trick hai basically with the help of which you don't really have to memorize anything. You can just figure it out there and then only. Okay? And also note their values in radian also to save some time. Then graphs, remember the shape of every trigonometric graph, the shape of the graph of sine, its properties such as its maximum value, minimum value, amplitude, and what is the period. The natural period of sine is 360 and so is the natural period of cos. Okay, maximum and minimum value also remain the same. For tan, the graph of tan goes to infinity at 90. After infinity starts from negative infinity at 180, it's equal to 0. And this is where the first period ends. After 180 is just a repeat, it's just another cycle. Okay, so there is no amplitude of the graph of tan. Why? Because it has no fixed maximum value, no fixed minimum value, but the natural period is pi or 180 degrees. And the reason why we have two cycles over here is because the range was from 0 to 360. ठीक हो गया? Then there are some variations. अच्छा, ये page बहुत important है. I've shared my notes with you guys, although you may not need it tomorrow, but later on, it's very important, especially these parts. How do you determine the new period? It's 360 divided by the coefficient of x, or 2 pi divided by the coefficient of x. How do you determine the new period of tan? It's 180 or pi divided by the coefficient of x. New step basically means that what should be the interval after which you plug in values. So it's 90 divided by the coefficient of x for sine and cos only, or 45 upon the coefficient of x for tan only. Notice that I've written a star here, which means sometimes step depends on the grid that is given, and the coefficient of x is not always equal to the number of cycles. Okay, so this is a very common mistake that people make, is that they think that the coefficient of x is always equal to the number of cycles. That is not the case. Okay, some example questions that I've done. Okay, now the kind of questions that you can get in paper 1 are the kind where maybe you have to draw graphs, some very basic ones, or maybe the ones where graph is given and you have to find out the equation. So for example, this is the graph of cos. How can we determine its amplitude? Maximum minus minimum divided by 2, that will be the amplitude. And what's the amplitude? The amplitude is the coefficient of the trigonometric function. So the amplitude is equals to 2. Now the graph of cos, if it has 2 amplitude, that means it's supposed to start at 2. But this graph is starting from 3. That means something must be added. And what is added? We can see that what is added is actually a. So a is equals to 3. Now, what is the period of this graph? The period of this graph is 120, so that means the new period equals to natural period upon the coefficient of x. The new period is 120, the natural period is 360 divided by the coefficient of x, which is c, so c equals 3. Okay? Okay, some more example questions that I've done. Some more. Achha, yeah, basic angle or theta, this I don't expect, because this we normally use to solve trigonometric equations. Okay? हाँ, ये ज़रूर है. Like for example, for values such as 0, 1 and minus 1, for example, if you want to find out when is sine equal to 0, when is sine equal to 1, when is sine equal to minus 1, for this you must recall the shape of the graph and then figure out these values. Like for example, cos x equals to 1, this happens at 2 separate values of x. And what are those 2 values? Those 2 values are 0 and 360. Okay, then we have some complex trigonometric equations. Now, if you have values like these, like for example, this or this, then you're supposed to remember exactly what the inverse is going to be. Why? Because you must have this table memorized. For example, if cos theta is equals to under root 2 upon 2, you must be able to recall that theta is equals to 45 in degrees or pi upon 4 in radian. Now, the kind of question of trigonometry that I expect to be tested are trigonometric identities. We solved plenty of those today. Did we do that today? Yeah, we did those today also. Okay. So I'm not going to go in a lot of detail, but just remember the rules of trigonometry. I will go over that. Always start with the more complex side, left hand side or right hand side, doesn't matter. Always bring every trigonometric function in terms of sine and slash or cos. Watch out for the third algebraic identity, that's a square minus b square equals to a plus b, a minus b. Do not treat it like an equation. Do not move values from the left to the right hand side or vice versa. But you can work on both sides. Okay, why can you work on both sides? So that you know exactly what needs to be done on the left hand side. Jaise ke, for example, here you can see the right hand side has tan x. If it has tan x, that means we need to make sure that the left hand side is equals to sin x upon cos x. Okay, so you can do that. It's not that big of a problem. Or for example, if let's suppose you're supposed to bring something, you're supposed to show that this is equal to sec theta. Ab sec theta kya hai? Sec theta is not something that's independent. Sec theta is 1 upon cos theta. So that means you can work on this side. Don't make it part of your working, but you can do it for yourself. Okay, I need to bring the left hand side to be equal to 1 upon cos theta. See kya? Just some range altering questions, which we are going to skip. Okay, now. Functions. Okay. Let's have a look at functions. So what is a function? A function is a relation where every input has only one output. So a relation is basically an equation. Input is domain, output is basically the image or the range. Not every function is a relation, but every function is a relation. Okay? A function can be of 2 types. A one-to-one function, which means one input gives one output. Many-to-one function, which means many or multiple inputs give one, or many inputs give one output. So for example, A one-to-many relation is not a function, like for example a circle. Why? Because if I plug in one value of x, I get multiple y values, which is why it's called one-to-many. A one-to-one function, remember, is either always increasing or always decreasing. It's never doing both. Whereas a many-to-one function is doing both. Okay, we can always turn a many-to-one function into a one-to-one function. More about that later. A circle, as you can see, is a one-to-many relation because there's one value that's giving many y values. A trigonometric function, cubic function, quadratic function are all examples of many-to-one functions. Now, graphical test can only be applied if the graph is given. Vertical line test is used to distinguish a function and a non-function. The condition to pass is that it should only cut it at one point. The condition to fail is that it should cut it at more than one point. So if a vertical line can only cut the function once, that means it is a function. But if it cuts it more than once, that means it's not a function. If a horizontal line cuts it once, that means it's a one-to-one function. But if it cuts it twice, that means it's a many-to-one function. Okay? Domain and range. Domain is basically all the values that you plug in. Range is basically what you get as a result. Now, in a one-to-one function, finding the range given the domain is very easy. Why? I've written a note over here. In order to find the range of a one-to-one function, we simply plug in the endpoints of the domain and give the answer in range form. But in order to find the range of a many-to-one function, we have to first find the minimum or maximum point, stating the range by either making a rough sketch, completing square form, or if it's a quadratic function. Differentiation can also be used. So if you have a quadratic function and you want to write down its range, or a trigonometric function and you want to write down its range, please make sure that you make a rough sketch first, then only you write down its range. Take care, don't try to do it directly. A lot of people think we can just plug in the value of x, write down the corresponding value, range aa gayi, aisa nahi hota. Take care, that's not how it works. So for example, if you have a quadratic function which inherently is a many-to-one function, you can turn it into a one-to-one function by altering the domain to greater than or equal to h, which is the x-coordinate of the turning point, or lesser than or equal to h, which is also the x-coordinate of the turning point. ठीक हो गया? Now functions की stream मैंने कल ही की है, उसको देख लीजिएगा अच्छी तरह से. We did composite function, especially the concept of composite function. Okay, the domain and range of composite function, especially the concept of that, which I did somewhere in between yesterday's stream. Make sure to check that out also. Okay, what's a composite function? Composite function is when you plug in one function inside the other function. Okay, that is basically what a composite function is. So then there are some past paper questions. Inverse of a function, some important rules regarding the inverse. Domain of f of x becomes the range of f inverse of x. Range of f of x becomes the domain of f inverse of x. F inverse of x is a reflection of f of x along the line y equals to x. Inverse of a function will only exist if it's a one-to-one function. Remember, for an inverse to exist, it has to be a one-to-one function. Okay? So a quadratic function will not have its inverse if we don't change its domain. However, if we change its domain, then the inverse will exist. Okay? Achha. Modulus. Okay. Now, how to sketch a modulus linear function? First, find out the x-coordinate of the vertex. What's a vertex? Vertex is basically the point where the two lines meet. By equating the expression inside the modulus to 0. So x minus 2 equals to 0, that means x equals to 2. Find the y-coordinate of the vertex by plugging in the x-coordinate of the vertex back into the equation. So when you plug that in, you get the y-coordinate of the vertex. Now plug in two values greater than the vertex, plug in two values lesser than the vertex. So notice that 2, 0 is the vertex. I plugged in 3, 4 to find these 2 points. Then I plugged in 0 and 1 to find out these 2 points. And now we have a V-shaped graph, which is what you will get every time you have a modulus function graph. Here also, equate the expression inside the modulus to 0 to find out the x-coordinate of the vertex. Plug this back into the function to find out the y-coordinate of the vertex. Then plug in some values greater than -3, some values lesser than -3. Take the modulus of it, write down the values, and then draw. Achha, this only applies if it's a linear graph. If it's a quadratic or cubic or trigonometric or any other type, then it's very simple. It's much simpler actually. You just draw it normally. Okay, so for example, you can see I've converted it into completed square form. I found out the x-intercepts, found the y-intercept. I drew a normal quadratic curve. Now, because it's modulus, that means whatever part is below the x-axis will now be reflected above the x-axis. So you either leave that dotted or you erase it altogether, and then you reflect the part that's below above the x-axis, and that's it. That's your answer. Okay? Some example questions that I've done, some more example questions. Okay, this is also an important question. So we have to draw the modulus of x square minus 8x plus 7. So x square minus 8x plus 7, we have converted it into completed square form in the previous part. We found out the turning point as well, and we're only supposed to draw it from 3 to ak. No, actually from 3 to 8. So we've drawn it from 3 to 8. At 3, we find out the corresponding value, that's minus 8, which when we take the modulus of it becomes positive 8. At 8, we find out the corresponding value, which is 7. Okay, so if I draw the actual curve, this is what we're looking at. But since this is modulus, that means whatever part is below the x-axis will now be reflected above the x-axis. So now this turning point 4 comma minus 10, 4 comma minus 9 actually, will now be here. And this point 3 comma minus 8 will actually be 3 comma positive 8. So this is what it looks like. अच्छा अब इस सवाल का एक interesting question है. Determine the largest value of k for which g inverse exists. Okay, and the range is greater than or equal to 3, lesser than or equal to k. So remember, inverse will only exist for as long as it's a one-to-one function, for as long as it's only going in one direction. The second it starts going in both directions, meaning it starts increasing and decreasing, it's no longer a one-to-one. So starting from 3, it's increasing, 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 increasing. At 4, it reaches its maximum value, then it starts to decrease. So that means it's only a one-to-one function for this range. So the greatest value of k is equals to 4. Acha, modulus inequalities. Remember, whenever the modulus sign is removed, you have to solve it with plus. You get a plus sign or a minus sign. Okay? Or another method is that you can square both sides and then solve. When you square both sides, you'll end up with a quadratic inequality, which means you'll have to use the concept of quadratic inequality to solve modulus inequality. Okay. I included some questions in the mocks also for practice. Now, whenever you have modulus on both sides, it's always a good idea to square both sides and then solve. ठीक है? अच्छा, अब आ जाओ graphs of E और ln x. देखो, simple से rules याद रख लो. The graph of E has a y-intercept and the coordinates are 0, 1. The graph of ln has an x-intercept and the coordinates are 1, 0. It's not a coincidence because they're inverse of one another along the line y equals to x. That is why you see the points being swapped. E power x is greater than 0. Its range is greater than 0 for all values of x. And its domain is all real values. Meaning you can plug in whatever you want. And the range will always be greater than 0. For ln, it's the opposite. Its range is all real values and its domain is greater than 0. Okay? As x approaches infinity, y approaches infinity as far as the graph of E is concerned. Same goes for ln. But as far as E is concerned, as x approaches minus infinity, y approaches 0. Here it's the opposite. As x approaches 0, y equals to negative infinity. Achha. Both of them have asymptotes. One has a vertical asymptote, the other has a horizontal asymptote. Whatever constant that you have with the equation, whether it's plus or minus, y equals to that value will be the horizontal asymptote. Equate the argument to 0 of an ln function and you have the equation of a vertical asymptote. Okay? This is the general rule for finding out the equation of. Achha, a lot of people have this question, how will we know whether the graphs are intersecting or not? You don't. There's no way to find out. Unless the question categorically tells you, or unless you draw it, okay, you mark the points through which the graph is passing, you follow the pattern, and if while following that pattern you realize that they intersect, they intersect. Simple as that. Okay, we did some questions yesterday. I would advise you to go over those questions to understand, okay, how do we know whether they're intersecting or not? Okay? Okay, now. Functions के बाद we have differentiation, integration, and then kinematics. Okay. So differentiation, what is the purpose of differentiation? Many purposes. We use it to find out gradient, we use it to find out the equation of tangent, the stationary value, the nature of stationary value, and whatnot. Rates of change, small change. How do you differentiate a power function? You multiply the power, take one away from the power. Derivative of a constant is equals to 0. If you cannot differentiate directly, then make sure that you write it separately so that it's easily differentiable, or as I like to call it, differentiation ready, and then you differentiate. ठीक हो गया. Composite functions, you first multiply the power with the entire function, you take one away from the power, and then you multiply it by the differential of the bracket. ठीक है. Product rule, when you cannot simplify and make one function, or if let's say you have two completely different functions, like for example an exponential or trigonometric, logarithmic and a trigonometric, that they're being multiplied, that is when you use product rule, which is vu prime plus uv prime. Quotient rule is when they're being divided, so that is vu prime minus uv prime upon v square. अच्छा, अब equation of tangent कैसे निकालते हैं? First of all, you differentiate the equation of the curve. You plug in the point, the x coordinate of the point where you're supposed to find out the equation of tangent. When you do that, you plug that in dy by dx, you get the gradient of tangent. Now you need a point. You complete the point by plugging in the x coordinate into the equation of the curve to find out the corresponding y coordinate. Then you make a nice equation out of it using this. But if you're asked to find out the equation of normal, you take the negative reciprocal of the gradient of tangent. ठीक है? So अच्छा, stationary point कैसे निकालते हैं? Whenever a curve turns, its dy by dx is equals to 0. Okay, but how do we distinguish whether it's maximum or minimum? We double differentiate, and when we double differentiate, we can either get a constant or we can get it in terms of x. If it's a constant, if it's positive, it's minimum. If it's negative, it's a maximum turning point. If it's in terms of x, which it will be majority of the times, then plug in the x coordinate of the turning point. If that, after doing that, you get a constant, you see whether it's positive or whether it's negative. If it's positive, it's minimum. If it's negative, it's maximum. All right, now alternative way to find out the nature of turning point, known as the first derivative test, this is it. If in dy by dx, you plug in a value that's greater than the x coordinate of the turning point and you get a positive result, and you plug in a value that's lesser than the x coordinate of the turning point and you get a negative result, that means it's a minimum point. Why? Because it means that the curve is actually decreasing. That's why you get a negative dy by dx before it turns, and after it turns, it's increasing. Okay, positive means that the curve is increasing, negative means that the curve is decreasing, and 0 means that it's stationary. So notice that it's decreasing, stationary, increasing, that's why it's a minimum point. You get a maximum point if it's the other way around. If it's positive first, that means it's increasing, then it's stationary, and then it's decreasing. So you can see that it's increasing, stationary, decreasing. That means it's a maximum point. Okay? Some example questions. Achha, rates of change. Remember the 3W approach that we use to solve any rates of change question. What is given, what you want, when do you want it? How do you make a chain rule? So for example, if you want to find out rate of increase of A, that means d upon dt. So this will come as a result of multiplying two fractions. Now numerator of the first fraction will always be equal to the numerator of what you want. Denominator of the second fraction will always be equal to the denominator of what you want. In the remaining two spots, you will write down something that's number one, equal and relevant to the question. So that means whatever you write here, you write the same value here. But it also should be relevant. So likhne ko to, I can also write dx, but dx is not relevant. Dx is nowhere to be found in the question. I can also write dh, but dh is not relevant. It's nowhere to be found in the question. What's relevant is dr, because we have dr upon dt and we can find dA upon dr, which basically means area differentiated with respect to r. So we are dealing with a circle. This is the equation for area, which if we differentiate, you get d upon dr. Take any rates of change question, it will be done this exact way only. Then there is small change, for which we have a formula, which is small change in x over small change in y equals to dy by dx. Okay, dy by dx at initial value of x. So that means if x increases from 2 to 2.0.5 or 2.05, that means 2 is the initial value of x. You plug that in dy by dx, get the initial dy by dx, and small change in x is already given. From 2 to 2.05, cross multiply, you get the answer. Something that you can expect in paper 1. All right, some more example questions. Such are practical applications. So just like how we find out the maximum value of A, minimum value of maximum value of Y, minimum value of Y, we can do that to area and volume also. Okay? Questions like these will always follow a specific format. That is, you will be given a certain piece of information and you will be asked to maybe make something else the subject for which you will use the information that's given. For example, here you're given the total surface area, you're given the length and the width, and you're given the height. So you're asked to express h in terms of x. You can do that by using the surface area equation. And notice that here you're asked to show that the volume is equals to a certain equation and it's in terms of x. Which means that if I find out the volume, I will get it in terms of x and h. But how do we have it? How can we have it in terms of x only? Answer is very simple. That's because we've already expressed h in terms of x, and we're going to use that. And if we do that, and if we do everything correctly, we will get exactly what the question says. Then if the question says v has a stationary value, that means dv upon dx equals to 0. If it asks you to find out the nature of the stationary value, then that means you will double differentiate, and the same rules that we applied to y apply over here also. Okay, now how do you differentiate an exponential function? Very simple. Exponential function as it is multiplied by the differential of the power. Okay, that's it. That's all there is. How do you differentiate a logarithmic function? 1 upon the argument multiplied by the differential of the argument. So if it's ln ax plus b, 1 upon the argument multiplied by the differential of the argument. This is the general rule here. Some past paper questions. Trigonometric functions. Remember this and this. So when you differentiate sine, you get cos, but you also have to multiply it by the differential of the angle. When you differentiate cos, you get minus sine and also multiplied by the differential of the angle. Differential of tan equals to sec square. So tan ax plus b, when you differentiate, becomes sec square ax plus b multiplied by ya, because a is the differential of the angle. Now, if you have a power, then remember this PTA rule. Okay, first we differentiate the power. That means n gets multiplied with the entire trigonometric function like we do it in a composite function. We take 1 away from the power, then we multiply it by the differential of the trigonometric function. That's where the t comes in. Then we multiply it by the differential of the angle. So sine raised to the power n ax plus b is equals to na sine power n minus 1 ax plus b into cos of ax plus b. Same rules applies to cos, same rules apply to tan as well. Some past paper questions, and that's it. Okay. Integration. Integration is nothing but the reverse process of differentiation. What do we use integration for? 2 reasons, and 2 reasons only. To find out the equation of the curve from dy by dx, and to find out the area under the curve. Okay. How do you integrate a power function? You add 1 to the power, divide by the new power, and there's always a plus c whenever you integrate. Okay. If you have dy by dx and you want to use it to find out the equation of the curve, you integrate following the rules of integration, and then whenever you integrate, you do a plus c. To find out the value of this c, you always need a point through which the curve is passing. We're given that point 0, 5, so we use that point to find out the value of c, and that completes our equation. Okay, integration of composite function, add 1 to the power, divide by the new power, and also divide by the differential of the bracket. Okay, the opposite of differentiation. Added 1 to the power, became 4, divide by the new power, divided by the differential of 2x plus 3, which is equal to 2. Some past paper questions, some more past paper questions. Integration of exponential functions, the exponential function as it is, divided by the differential of the power. That's it. Okay. Okay, some more past paper questions. Integration leading to ln. So I did some questions of this recently only. If the numerator is equal to the differential of the denominator, or if it can be made equal to the differential by multiplying with a constant, then integration leading to ln is used. So basically look for a situation like this, where the numerator is exactly equal to the differential of the denominator. If that's the case, then integral of this will basically be ln of the denominator as it is, plus c. Plus c is something that we have every time we integrate. Okay? So for example, 3 is the exact differential of 3x minus 1, therefore ln 3x minus 1 is the answer. 2x plus 1 is exactly what you get when you differentiate x squared plus x minus 6, so therefore the answer is ln x squared plus x minus 6. Achha, what to do if it's not exactly equal to 1? Then sabse pehle clean up. Clean up basically means that you bring the 4 outside. So as soon as you bring the 4 outside, the numerator is equals to 1. Now 1 can easily be manipulated. 1 ko hum jisse multiply karenge wo ban jayega. So if I multiply 1 by 2, that means the numerator is now equal to the differential of the denominator, but I can't just leave it there. I have to divide it by 2 also. So I divide the constant outside by 2. So you can, now this is exactly in this form, which means that I can simply write it like this. Okay? Note, remember, if you multiply a constant, make sure to divide by the same constant as well, but outside of the integral sign. Another example where we've cleaned up first and then made the numerator equal to the differential of the denominator. Some example questions. Integration of trigonometric functions, the quite exact opposite of differentiation. In differentiation, we multiply by the differential of the angle. In integration, we divide. So if the differential of sine is cos, the integral of cos is sine. The differential of cos is minus sine, the integral of sine is minus cos, except that we also divide by the differential of the angle. The differential of tan is sec squared, the integral of sec squared is tan. Some past paper questions that you guys can review. Acha. Integration to find area under the curve. Okay? Ab remember that the 4 things that you use when you're integrating, that is what equation you're integrating, what limits you're using, what with respect to you're integrating. Okay? So the equation, the 2 limits, and what is it with respect to that you're integrating, they become the boundaries. So that means if I integrate the equation of f of x within the limits b and a with respect to x, that means I will end up finding the area. Since I'm integrating with respect to x, I'll end up finding the area that's bounded by the x-axis. Since one limit is x equals to b, that means I'll end up finding out the area such that where one boundary is x equals to b. Since x equals to a is another limit, the other boundary is x equals to a. And since we're integrating the curve y equals to f of x, that means this is the area that we will end up finding. Okay? Achha. If you have a complex shape like this and you're supposed to find out the area of shaded region, planning is very important. You must have heard me say this. If you fail to plan, you plan to fail. Okay? Planning can be something very basic. So I can't just find out the area of the shaded region directly. I'll have to do it in bits and pieces. So first I will find out the area under the line, which by the way is a trapezium. So you can do it like a trapezium or you can do it like a straight line also. That will give me all this area, but I don't want that. Then we will integrate the curve within the limit 0 and 2. So we will have area under the curve, and then when we subtract them, we will get exactly what we want. Okay? So planning, remember, is very important part of finding the area of shaded region. Achha, इसमें एक important चीज़ वो क्या कि if let's suppose the area is, I'm skipping this because we have done a stream on this recently only. If let's suppose the area is below the x-axis. When part of a curve is below the x-axis, the answer after integrating within limits will come out as negative, but since we need to find out the area, we will ignore the negative sign and give the answer as positive. Okay? For example, if you integrate this, you will get the answer as negative. Now this is your calculator's way of telling you that the area that you're trying to find is actually below the x-axis. So what you do is you just put a modulus around it to make sure that you take it as positive only. And then when you find out this region, you will get a positive answer only, so no need to do anything to it. Okay? Then some hence find questions, which we also did in the last stream. अच्छा फिर कुछ questions देख लेते हैं जिसमें we have to, नहीं ठीक है काफ़ी है. Okay, now kinematics, something that we just did recently. Okay, let's go over the notes of this. So what's the difference between distance and displacement? Distance is the total number of units covered. Displacement is how far away the object is from the starting point. Okay? Achha, for as long as the object does not turn, distance equals displacement. When the object is back to the starting point, displacement is equals to 0, not necessarily velocity, not necessarily acceleration. Velocity is equals to 0 if the object turns or if the object has come to a stop. It's the end of the journey. Okay, we'll talk about that later. Acceleration is equals to 0 if the object is not moving or if the object is moving at a constant velocity. If the object goes beyond the starting point, return journey displacement becomes negative. So if the object on the return journey has gone beyond the starting point at t3, notice that what is its displacement? Its displacement is -8. Why? Because that's how far away the object is from the starting point. Okay, now speed versus velocity. Speed is always positive. Velocity can be positive or negative. Okay, velocity, if the object is going in the opposite direction after turning, it's going to be negative. So what is acceleration? It is the rate of change of velocity. Velocity is increasing means the object is accelerating. If the velocity is decreasing, that means the object is decelerating. If the velocity is constant, that means the acceleration is equals to 0. Okay, some important key points now. Distance from O, fixed point, is called displacement. When an object starts from O at t equals to 0, the displacement is equals to 0. Not necessarily the velocity, not necessarily the acceleration, but the displacement at t equals to 0, t equals to 0 is equals to 0. If the object starts from rest, then when t is equals to 0, the velocity is equals to 0. The differential of displacement with respect to time gives velocity. So when you differentiate displacement with respect to time, you get velocity. The differential of velocity with respect to time gives acceleration. So if you differentiate velocity with respect to time, we get acceleration. We solved some questions as well. At maximum displacement, velocity is equals to 0. Think of a ball, you throw it up in the air. When it reaches its maximum height, its velocity is equals to 0. At maximum velocity, acceleration is equals to 0. When the object is instantaneously at rest, that means its velocity is equals to 0. When velocity equals to 0, there are two possibilities. One is that it's the end of the journey. Like for example, a car is parked, end of journey, velocity is equals to 0. Or the object has turned or object has reached the turning point. Okay? So that is also an instant when the object is equals to 0. In order to find out if the object is turning or not, simply equate the velocity is equals to 0. If you're asked to find out initial value of anything, whether it's displacement, velocity, or acceleration, simply plug in t equals to 0. For example, if you want initial displacement, plug in t equals to 0 in the displacement equation. If you want initial velocity, plug in t equals to 0 in the velocity equation. If you want initial acceleration, plug in t equals to 0 in the acceleration equation. When the object is back to the starting point, displacement is equals to 0. Area under the velocity time graph gives the distance traveled. If area is negative, it means the object has gone beyond the starting point in the opposite direction. For as long as the object does not turn, displacement equals to distance. I think I've already written that, but anyway. If the object turns, then first find out critical values of t, that is when the object turns, before finding the total distance traveled. Okay, we did a question similar to this. And you can either do it by integration or you can do it using the table method. Okay? Table method is a game changer. Stick to that. Conversion of graphs. If the distance time graph is an upward sloping line, that means velocity is constant, acceleration is equals to 0. If the displacement time graph or distance time graph is a downward sloping line, that means velocity is constant, but it's negative. Why? Because it's traveling in the opposite direction and acceleration is equal to 0. If it's an increasing curve, that means the velocity is increasing and the acceleration is constant. Okay? If it's a decreasing curve, that means the velocity is decreasing and the deceleration is constant. Notice that it's negative, that means it's decelerating. Okay? A straight line means a straight line in a velocity time graph, doesn't matter whether it's upward sloping or downward sloping, means constant acceleration. Okay, why? Because gradient of this velocity time graph is equals to acceleration. अच्छा, some example questions. ये वही question है जो मैं बोल रहा था कि today when I was solving kinematics, I said that, I'm getting this deja vu-ish feeling, and that's basically because of this question, which came in May, June 2022. Okay, so I solved a question very similar to this in today's stream. Achha, some more example questions. Just remember that if the object is turning, make sure that you find out the point at which it's turning before you go ahead and find out the total distance that it travels. Okay? I did a question where we had to deal with such a concept, so make sure to review that. And I guess that's it. Okay, so I'll enable the chat for a while, see what you guys have to say. But I'll just give you guys some tips as to how to go about tomorrow's paper and what sequence in which you need to attempt the questions. Okay, just some general tips, nothing too complicated, nothing that I haven't said already. So yeah. Okay, so how to get position vector? Position vector basically means the starting point is O. Unit vector, if the question says so, if the question is asking you to find out the unit vector, you find out the unit vector, which basically means vector divided by its magnitude. Acha, sir, how are we going to find when they said they never collide? They never collide means that the values of t will be different. Acha, sir, we can use y equals to mx plus c. Of course, you can do that. When to decide x limits or y limits? Dekho, every question, whether it's if it's of area under the curve, can be done using x as the limits only. ठीक है? वो y limits वाली चीज़ मैं करा तो देता हूँ, but it's not something that is officially part of your syllabus. Sir, your kinematics notes, you only have 6 pages. अच्छा, तो एक काम करो, kinematics के notes में अगर pages कम हैं, चलो मैं upload कर देता हूँ. ठीक है, then you can just download it from the last kinematic stream, but I'll update the notes also. Okay, now, so when to use small change formula and chain rule? If the small change, you use the formula if the question says find out the small change. If the question is of rates of change, you use the chain rule. That's it. How do we draw inverse graph of quadratic functions? You reflect every point along the line y equals to x. Okay, whatever inverse you have to draw, you have to basically swap the y values with x values and x with y. Okay. Achha, what's that? Sir, as you said, there are some topics which you haven't seen coming in P1 but more in P2. Can you point those out? Permutation combination ke questions ho gaye, binomial, the expansion part, and trigonometric equations. That. Okay, but again, I could be wrong. Okay, I could be wrong. So don't make a rule out of it that these are never tested in paper 1 or paper 2. Okay. Anything to memorize? Yes, all the derivatives, differential of sine, cos, and tan, all the values, sine, cos, tan values of 0, 45, 0, 30, 45, 60, 90, graphs of sine, cos, and tan, all that stuff you have to memorize. No, I don't have a formula sheet. I don't have a formula sheet. Sir, do we do modulus for velocity to speed graph? No, but if you have found the velocity and the question is asking for speed, give your answer as positive. So independent term of binomial, but I don't know what, don't ask me what can come, what cannot. Okay, I'm sure you've solved enough past papers. Ab kal kya aayega, kya nahi aayega, I don't know. Okay, I can't answer that. But I hope you've done enough past papers so that you know what to expect. So what if the values of t are same but negative? Do they still collide? No, of course not. But if t is negative, that means it's not possible. How do we know if the graph and its inverse intersect or not? You just draw it the normal way. If they intersect, that's great. If they don't, that's it. Okay? There is nothing that you're going to do. Acha, guys. Ab zara कुछ important tips आप लोगों के लिए, ठीक है? So pay attention. Okay, so first of all, just a second. देखो, at this point, I'm sure you guys are all, if you've worked hard, I'm sure you all are feeling nervous. You all maybe getting that anxiety. Okay, what if we miss out something? Have we done enough? Should we make the most of whatever time it is that we have left? I'm sure a lot of you must be feeling that way. But remember, part of your preparation is that you get a good night's sleep. Majority, in fact, every one of you have your paper tomorrow at AM. So it's very important that you guys get a good night's sleep. Okay? Trust me, you do not want to be in the state where you look at a question and then after you're done with the exam, you're like, oh crap, I wish I had thought of that in the exam, or I wish that occurred to me in the exam. Okay, and you will end up doing that if you don't get a good night's sleep. Okay, AdMath and math, any form of any paper like math, AdMath, physics, chemistry is such that you need a fully functioning brain to be able to think on your feet. Like for example, what if you come across a tricky kinematics question? What if you come across a tricky vectors question? What if you come across a tricky trigonometry question that you can't figure out? Maybe Maybe there are multiple solutions, but you're only able to figure out one. Maybe you've gotten multiple solutions, but you know that only one is valid, which by the way happens if you're solving a logarithmic equation. Make sure that you read the question carefully, whether the question is asking for find out the values of x, whether the question is using the word singular. Look at, every time you have a question like this where you get multiple values, the question will give you that t is greater than 0 or x is greater than 0. That's the question dropping a hint that, maybe we have to choose by looking at the condition that's given, and that could mean that we will get multiple values and we have to choose one. So make sure that you guys are reading the question carefully. Do not doom solve. Make sure that you're aware of the context of the question. You're fully invested in the question. The value of t that you get makes sense. The argument that you get makes sense. The angle that you get makes sense. The point of intersection that you get makes sense. The gradient that you get makes sense. The area that you get makes sense. If you're doom solving, if you're not really paying attention to the question, if you're just solving just for the sake of getting the answer, whether that makes sense or not, you can't blame the subject. It's just that you're not doing what you're supposed to. Okay, and don't ego solve also, especially if, let's say, you're solving a polynomial. May, when you have fractional and you have to plug in like fractional values and you have to cube it, you have to square it, you have to multiply, subtract and all that, you may be tempted to, just work it out mentally. Don't do that. If you have to formally take out the LCM, then do it. Okay? You don't want to lose marks because of silly errors. Okay? See, if you lose marks because you're unable to attempt a question, you do not feel too bad. Okay? But if you lose marks because you know that you could have done it correctly, but you're getting it wrong just because you did not pay enough attention, that is when you feel really bad. That is basically something that was preventable. See, if you get a question that you simply cannot solve, even if you hear someone telling you how you're supposed to solve it and you still don't get it, you're not going to feel too bad. I mean, you're going to feel bad that you've lost marks, but it's not preventable. But losing marks because of silly errors is preventable. So for that, follow the 3-to-1 rule. 3-to-1 rule basically means that every time you do 3 lines of working, you pause for 2 seconds, you review the work once. Okay, remember 3-to-1. 3 lines of working, pause for 2 seconds, review the work once. Before you start solving a quadratic equation, make sure that you check everything that you've done, whether you've done it correctly or not. Before you solve a trigonometric equation, make sure that you check whether you've done everything correctly or not. Before you move on and let's say if you've solved a cubic polynomial and you want to check whether you've done it correctly or not, you can do that by plugging in the values back into the equation. You can do the same for logarithmic equations. For every equation that you solve, you can actually do that. Okay? You can actually double check your point of intersection, whether it's correct or not, by plugging in the x and in the original equation and seeing whether it gives you the same y value or not. Okay? Just the same can be done for simultaneous as well. Make sure that you read the question carefully for whether the question is saying real roots, real and equal roots, no real roots. Make sure you read the question carefully for differentiation, whether it's asking for equation of tangent, equation of normal, stationary value, whether you're supposed to find out the x coordinate or the coordinates or only the y value. So just make sure you guys read the question carefully. I cannot emphasize on this enough. Okay? Acha. What to expect in the paper? So after the change in format, we get like 12 and 13 questions in the exam. So be mentally prepared for 2-3 difficult questions. Okay, 2, maximum 3 difficult questions, but don't let those 2-3 difficult questions ruin your entire paper. Okay? Just skim through the paper first. Start with the easier ones. For example, quadratics, start with that. Do the polynomial question first. Polynomials, no matter how difficult it gets, it's still on the easier side. Then look at questions of what else do you have? Modulus. If let's say you have a question related to modulus, they're also mostly on the easier side, so do that question first. Then if you have a question that is related to, hang on, let me actually keep a past paper in front of me so that I can guide you guys better. Then let's suppose if you have a question that is related to APGP, you find that easy, do that first. So all the lengthy questions such as differentiation, integration, or if it's vectors that require planning, please make sure that you spend ample time planning. Okay, if you have to find out the area of shaded region, remember my words that if you fail to plan, you plan to fail. Okay? So make sure that you plan your answer. You don't just doom solve. If it's area of shaded region and it requires multiple steps, then make sure you write down those steps before you start. If you're using substitution, make sure that you mention whatever substitution it is that you have used. Okay, or whatever it is that you're doing. If let's say you have to don't just assume that the examiner will know this or the examiner will figure this out on your behalf. Remember, you're communicating with the examiner not the way that we're communicating. You're communicating with the examiner through your working. So make sure that your working is clear. If let's suppose the question is of trigonometry and the question says, or maybe kinematics and the question says where it's first at rest. So remember, the word first has some significance. That means maybe we'll get multiple values and we only have to pick the first one. Okay? If let's say you're solving a question which involves equation of circles, then make sure that you make a rough sketch, that you understand the context of the question. Same goes for, where you have questions where you have to find out the equation of tangent and the point at which the tangent cuts the x-axis, the y-axis, then you have to find out the area and all that kind of stuff. Make sure that you make a rough sketch, and while making a rough sketch, make sure that your sketch makes sense. If the line is upward sloping, if a line has a positive gradient, it should be upward sloping. If it has a negative gradient, it should be downward sloping. The place where you place the point should also make sense. If you're making a rough sketch, then remember, you can always make the sketch first and then mark the values later. Okay? So that's it, I guess. I hope I haven't missed out anything. If you solve a modulus question, then you know that you can always plug in the values that you get back into the equation and see if it holds up or not. So these little things, if you do, they will give you, they'll give you a confidence boost. When you know that you've done something correctly, you know that you've so many marks are guaranteed. You will feel more confident as you approach the difficult questions, okay? Which I once again recommend that you do towards the very end, okay? If God forbid there is a question that you cannot solve, don't let that question ruin your entire paper. Leave it, come back to it later, okay? Don't think of time as 2 hours, think of it as 120 minutes. You will be able to keep track of it better if you use a smaller unit such as minutes, and keep track of time, but don't lose your focus for even a single second, okay? I hope, I don't know if you guys can carry your own water bottle, but do that. I understand that it's unbearably hot, but please don't drink a lot of water so that you have to go to the restroom again and again. You'll end up wasting time. So just make sure that you are prepared to sit in one place and solve the paper without taking a break that's longer than 5 seconds for 2 hours. Okay? And please don't do anything out of routine. Don't eat anything out of routine. Get a good night's sleep. Very important. I cannot emphasize on how important it is. Getting a good night's sleep. I'm afraid, although I hope I'm wrong, but I'm afraid a lot of you will actually not pay attention to this advice, will not value this advice, and pull an all-nighter. I don't know what, but what I can guarantee that if you do that, what you will end up doing is that you will end up ruining your preparation. All the hard work that you've done for the past 2-3 years, if you want to ruin it, pull an all-nighter. That's the most unproductive thing that you can do. Okay? So I hope you guys will pay attention to that advice and not do what I said you shouldn't and do exactly what I said you should. Okay, so that's it. That's it from my side. And when you guys are done with the exam, make sure that you come back and tell me exactly what was tested so I can make paper 2 mocks for you guys with the, not just the concepts, but with the, not just the topics, but with the concepts as well. Okay, so I'll be waiting to hear from you guys, and I wish you guys the best of luck. Say your prayers before you start the paper, and pray for yourself, pray for your family members, your classmates, whoever has been a part of this journey with you, me also. And yeah, that's it. I'll speak to you guys inshallah tomorrow. And remember, I'll be waiting for you to hear from you guys to tell me exactly what was tested so we can prepare better for paper 2. Theek ho gaya? So take care. Allah Hafiz. Sir, velocity vector came in 2026 February March paper. That is true. But does that mean that it's a standard rule now? It's a standard practice that it will always come in February March? No. The kind of question that came, even kinematics came. Even kinematics came. So does that mean that it's a standard practice? Of course not. Okay, so if it comes in paper 1, that means it is designed to be done without a calculator. Okay. So sometimes the graphs of e-power are not the usual shapes. Can you please tell which scenario is that? Look at yesterday's stream. In yesterday's stream, I solved some questions where I drew some graphs of e power x and ln x and their inverse. So you will see what I'm talking about. You'll understand what I'm talking about. Okay, but you'll have to look at yesterday's stream. At this point, just pull the plug. You might feel that I concept kar loon, I should probably do this concept, I should probably ask sir to explain this concept. Not going to help. At this point, just pull the plug. That's it. Now, what you're saying उसमें the fundamentals don't change. The rules that we follow to sketch the graph of E and the rules that we follow to sketch the graph of ln don't change. So if you know your fundamentals, it's not going to be a problem. ठीक है? I have gone over some NCR and NPR questions in this stream. Okay? I have gone over some NCR and NPR questions in the stream. You can have a look at that, and you can also download the notes in the description to have a look at how to do those questions. Okay? So at this point, the stress of sleeping is going to be harder than the paper. See, if you don't, the choice is yours. Either sleep and have a fully functioning brain tomorrow, and you don't have to feel guilty by sleeping. You don't have to feel guilty by sleeping that you're not putting in effort, or you should be making you should be using your time more productively. Sleeping is actually the most productive thing that you can do. Okay? Yes, you can follow the loop method. Start with the easy questions. Leave the difficult questions for the end. Simple as that. Okay? Okay. So I'll stop here, guys. And see you guys. I'll speak to you guys tomorrow, inshallah. So that's it from my side. Yes, pencil for all graphs. Read the instructions on the question paper. It says pencil for all graphs. Okay? So I'll stop here. See you guys, inshallah, very soon. So take care, fellas. Once again, Allah Hafiz.